The problem that I had the most trouble with was problem number 4, part A. In this problem, there's a rock climber with mass 60 kilograms, and she stops for a break by leaning back on her rope, as you can see in this picture. And the rope has unknown tension and makes an angle of 31 degrees with the wall, and the wall also exerts a force on the climber that points at an angle of 15 degrees above the horizontal. The question is to find the magnitude of the tension in the rope needed for the climber to stay stationary. So let's start with a free body diagram. The dot is the climber, FC, the force of the wall, points in the positive X and Y direction and makes a 15-degree angle with the horizontal. FT is the tension force, and it points in the positive Y and negative X direction and makes a 31-degree angle with the wall. And FG is the force of gravity, and it points in the negative Y direction only. So we know that the climber is at rest, therefore her change in momentum is equal to 0. And by Newton's second law, we know that the change in momentum is equal to F net times delta t. And since the change in momentum is equal to 0, that means that F net is equal to 0. And F net in this problem is equal to Ft plus Fc plus Fg. And we must break those down into the Y and X directions. So in the Y direction, Fty plus Fcy plus Fg is equal to 0, and in the X direction we only have Ftx plus Fcx equaling to 0. So in order to find the X and Y components of the tension and contact force in terms of their magnitudes, we must use trig. So for the tension force, Fty is equal to the magnitude of the tension force times cosine of 31 degrees, and Ftx is equal to the negative magnitude of the tension force times sine 31, and Fcy is equal to the magnitude of Fc times sine 15, and Fcx is equal to the magnitude of Fc times cosine of 15. And we must use those equations and plug it back into the equations that we came up with previously with the forces in the X and Y directions. So in the Y direction, we have the magnitude of Ft cosine 31 plus magnitude of Fc sine 15 minus mg, which is the force of gravity, equals to 0. And in the X direction, we have the magnitude of Fc cosine 15 minus the magnitude of Ft sine 31 equals to 0. And we can write the magnitude of the contact force in terms of the magnitude of the tension force, and it's equal to the magnitude of Ft times sine 31 divided by cosine of 15. And we're going to use that equation to plug it back into the equations of all the Y components of the forces. So Ft cosine of 31 plus Fc, which is also equal to the magnitude of Ft sine 31 divided by cosine 15 times sine 15 minus mg is equal to 0. And I moved mg to the other side and solved for the magnitude of the tension force, and it became equal to mg divided by cosine 31 plus sine 31 times tan 15. And when you plug in the mass and the gravitational constant, and the mass is 60 kilograms and the gravitational constant near the earth is 9.8 meters per second squared, and that is equal to 591 newtons.